Hello, good evening, and welcome back to another segment of WWSN, Worldwide Science Network. 2 days ago, the network sent me to Dr. Fakini's lab, where she helped us to gain some new intel on what this new exciting discovery is all about. Today is the day I'm going to Dr. Fakini's lab to learn about meiosis. I have no idea what it is, and I need to get prepared, so let's do it! Sorry I'm late, but I'm here and I'm ready.
What are you doing?
You know, I'm preparing for whatever you're going to throw at me.
What do you mean? This is meiosis, not a tennis match. Go get changed, and the only thing I'm throwing at you are these balls.
What?
Now that that's all taken care of, welcome to my lab. It's a pleasure to have you here today. Are you hyped to learn about some science?
Of course, I'm so excited to be here. But, you know, to learn about
Meiosis!
Yes, of course, that's what it's called. But what exactly is meiosis?
So, meiosis is the process of cell division that involves a reduction of the chromosome number to the 1/2, the normal chromosome, producing genetically diverse cells. Well, that's just a formal definition. Let me show you step by step what the process of meiosis is all about. Follow me.
Before we start, can you just teach me about the background information of what meiosis truly is?
Of course. So, the purpose of meiosis is to make genetically diverse sex cells. Did you know that diploid cells comprise majority of the cells in the human body? These are cells that contain pairs of homologous chromosomes. These cells have twice the number of chromosomes as haploid cells, which are most commonly gametes used in the reproduction of sex cells.
Wow, that's so cool! Wow, that was so interesting. I can't wait to see a step-by-step process.
I'm glad you liked it. It's so simple that my team and I have set up a demonstration for you, and by the end of the night, you'll be teaching us all about meiosis.
I'm so excited!
Shall we head in?
Yes, let's go. Before the process of meiosis begins, the cell first has to go through interphase. The cell replicates all its single-stranded chromosomes as it prepares for division. Prophase 1. Each pair of homologous chromosomes line up side by side. This aligning is called synapsis. During synapsis, the homologous chromosomes are held tightly together. As they are lined up, segments of the chromosomes may be exchanged. This is known as crossing over, when some of the DNA from each chromosome is shared. The centrosomes move to the poles of the cell, and the spindle fiber apparatuses form. Metaphase 1. The nuclear membrane has disappeared, and the homologous chromosomes line up along the equator of the cell. These homologous chromosome pairs are called tetrads. The orientation of each pair is random. The spindle fibers attach to the centromere of each homologous chromosome. Anaphase 1. The homologous chromosomes separate and move to the opposite sides of the poles of the cell. The separation of the homologous pairs is known as disjunction. Because the sister chromatids are still held together, their centromeres do not split. Therefore, a single chromosome made up of two sister chromatids from each homologous pair moves to each pole of the cell. The chromosome number is reduced from diploid to haploid. Telophase 1. The homologous chromosomes begin to uncoil, and the spindle fibers disappear. Cytokinesis takes place, and a nuclear membrane forms around each group of homologous chromosomes. Two new cells form. Each of these new cells is now haploid. This is the start of meiosis II. The key difference in meiosis II is that the cell that undergoes division are haploid instead of diploid. Prophase II. Spindle fibers reform and attach to the centromeres. Metaphase II. A haploid number of chromosomes line up at the equator in preparation for the centromeres to divide into the next phase.
Anaphase 2. The sister chromatids are pulled apart by the centromere by spindle fibers. The chromosomes move towards opposite poles of the cell. Telophase 2. The chromosomes reach the poles and the nuclear membrane and nuclei reform. A part of this stage includes the pinching in of the cell membrane, resulting in 4 haploid cells. From these haploid cells, they become specialized reproductive cells.
What are you doing?
I am, trying to find some scientific reason why this tread machine will not work. Well, I'm just gonna take my weights and, see you next week.
Hi, and welcome back to WWSN. I hope you enjoyed this week's segment on meiosis. Please stay tuned for next week's segment on spermatogenesis and oogenesis. Thank you for watching, and I hope you all enjoyed. Bye!